Welcome to the Foundry by Forge College. I am so excited to have you here for this explainer. Today, we're laying out an engineering blueprint for deploying your Solana programs. We're taking a real kind of architectural approach to this topic. Think of it as your master schematic for taking your code out of your safe, cozy local garage and tossing it onto the totally unforgiving global network.
Okay, here's a quick look at the master schematic for the Solana Deployment Fundamentals module. We're going to start by moving from Capstone to Cluster, break down our core components, and then walk through the 5-phase workflow. After that, we'll map out deployment roles, move from code to CLI commands, and wrap the whole thing up with a blueprint recap. Let's get right into it.
Section 1. From Capstone to Cluster, moving your local parts to the network. So in our previous lesson, you tackled the Capstone build. You successfully wrote, compiled, and tested a small Rust program for Solana. Seriously, you should be really proud of that. You basically built a beautiful, high-performance engine piece right there on your local workbench. You've got your compiled program binary, you fired off some local test transactions, and you proved that your logic is totally sound.
But here comes the most famous and, let's be honest, sometimes the most terrifying phrase in all of software engineering. It works locally, now what? Right? I mean, it's incredibly safe and cozy on your local validator. Nobody can break it. But you didn't build it just to keep it locked up in the garage. Taking that leap to the live network can feel a little daunting. Like, how does this binary actually move to a managed deployment? Who owns what step? What resources do we actually need? Well, that is exactly what this explainer is going to tackle. We're going to figure out how to allocate resources, assign roles, and actually install this piece into the real roaring engine of the Solana network.
Moving on to Section 2. Core deployment components. Identifying our mechanical materials. So, before we fire up the machine, we really need to distinguish between 3 fundamental materials we're going to be working with. First up, we've got artifacts. Think of these as the physical gears of our machine. It's absolutely crucial to understand that the Solana cluster does not want your raw source code. No way. It only accepts packaged and signed bytes. When you build your Rust program, the output is an ELF binary, which is a specialized format just for the Solana BPF runtime. These binaries, along with any initialization scripts, well, those are your deployment artifacts. You have to plan out exactly how this binary will be stored and tracked. Next up, we have resources. If artifacts are the gears, then resources are the fuel, and really the physical space the machine takes up. Deploying a program consumes on-chain resources. You're going to need program accounts to store those bytes we just talked about, and you need state accounts for any data your program creates. And crucially, you need LAM ports to fund the rent-exempt balances for these accounts. I always like to think of rent exemption as a security deposit on a storage unit. If you want to keep your data on-chain forever, you got to lock up enough LAM ports to pay that deposit.
Finally, we have governance controls. These are literally the control valves of your machine. This includes the cryptographic keys used for program upgrades, multi-sig authorities, and the approval gates in your CI/CD pipelines. And let me tell you, there are very few things more terrifying in Web3 than the sheer panic of realizing you've misplaced an upgrade authority key. It's a total nightmare. Governance is simply how you make sure that the only people turning the dials on your deployed program are the people actually authorized to do so.
Now, this governance spectrum essentially dictates your entire deployment strategy. On one side, you have an immutable deployment. This is basically like welding the machine shut once it's built. You disable the program upgrade authority entirely. It massively reduces the risk of malicious or accidental upgrades because literally no one can change the code. But on the other side, we have an upgradable deployment. This preserves an authority key, allowing you to iterate and patch bugs. But it requires incredibly strict key custody protocols. You got to map this strategy to your organizational needs. If you need rapid iteration, go upgradable, but for sure, guard that key with your life. If you need maximum provable stability, weld it shut and go immutable.
All right, Section 3, the 5-phase workflow, moving down the assembly line.
Here is a core philosophy we really emphasize. We want to turn chaotic, ad hoc terminal commands into a repeatable, auditable blueprint. So let's walk down this 5-phase assembly line. Step 1 is prepare. This is where you collect your artifacts, your binaries, version metadata, upgrade keys, and parakeys pairs. Step 2 is validate. We are not guessing here. We run functional checks against the local validator, and, crucially, we run a reproducible build step to verify the checksum of our binary.
Step 3 is stage. This is your dress rehearsal on a staging cluster like DevNet. You run the exact deployment scripts you plan to use in production. Then, step 4 is release, the big red button. You lock down approvals, schedule a window, execute the commands on mainnet, and run post-deploy smoke tests. And finally, step 5, operate. You don't just walk away. You monitor your service level objectives, set up your alerts, and maintain the machine.
Section 4. Mapping deployment roles. Who exactly pulls which levers?
A complex machine needs clear operators, right? Explicitly naming these roles drastically reduces ambiguity when you're in the middle of a live release. We map our checklist items directly to the people responsible. During the prepare phase, the build engineer is the one handling the gears, ensuring we have a reproducible build and a verified checksum. Moving right into validate, the QA or integration engineer takes over to run tests. When we hit the stage phase, the release manager steps in to run the dry run on DevNet. And finally, for the release phase, the actual production deploy, the release manager works right alongside the on-call team to pull that lever and verify the post-checks. Defining all this up front prevents that classic awful scenario where everyone says, wait, I thought you were deploying it.
Okay, Section 5, Code to CLI Commands, the test drive.
Now that we have the theory down, let's see how these abstract concepts turn into actual executable code in command line instructions. Remember the Rust code from your capstone? At the very core of your program is the process instruction entry point. This function takes the program ID, the accounts, and the instruction data. When you compile your project, this exact logic, along with all your state handling, gets compressed down into that specialized ELF binary artifact we discussed earlier. It goes straight from human-readable Rust into the bytecode language of the Solana BPF loader.
And here is exactly how we command the machine to do that. The first command, cargo build BAPF, well, that's the magic that creates your artifact. It packages everything up for release. The second command, Solana program deploy, is the ignition. It takes that binary path, reads your keys, and fires the payload directly into the cluster endpoint specified by your URL, like devnet or mainnet-beta. This is the exact moment where your artifacts, resources, and governance all collide in one single terminal execution.
Which brings us to Section 6, Blueprint Recap and Next, signing off on the schematic.
So, let's lock in these 3 practical principles. First, always separate your concerns, manage your artifacts, plan your on-chain resources, and secure your governance controls as totally distinct categories. Second, choose your strategy deliberately. Decide right up front if you're welding the machine shut with an immutable deploy or if you're keeping the keys for an upgradable one. And third, make deployment a rehearsed workflow. Testing in production is a literal horror story you do not want to star in. Use playbooks, run staging dry runs, and execute those smoke tests so that your live release is completely boring and predictable.
You have built the conceptual blueprint. You know the parts, the resources, and the roles. So here is my final question for you. Are you ready to map these artifacts into your own step-by-step production release script? Because that is exactly what we're going to be tackling in the next phase of your learning journey as we dive into specific checklists. I highly encourage you to keep exploring, so please visit forge.college to learn more about this subject, access our other programs, and dive deeper into everything Web3. Keep building, keep testing, and I'll see you in the next explainer.